طبعا إن شاء الله بيكون recorded. If you miss anything, you'll be able to go back and check. طيب, بسم الله الرحمن الرحيم. The way I'm going to conduct this problem session is the following. So there's an old exam here. I found it I think in the student resources. So I'm going to solve some of the questions, not all of them. And I believe I'm going to post this old exam as well. It's available in the KFUPM resources, I think. Then I will move to another exam, inshallah, if we have time, and I will solve some parts. Or this is for exam 1. I think there's for exam 2. I'm going to solve some problems from exam 2, because in the previous semester it used to be midterm 1, major exam 1, major exam 2, and final. But this semester is we are going to only have one midterm. So the material will be the coverage for the midterm is kind of like what we used to cover, or what they used to cover on exam 1 plus some part of exam 2. Anyhow, so let's get started. طيب بسوي لكم كلكم mute, so if you want to ask a question, unmute yourself. Okay. So let me copy this circuit. So let's try to solve this one. So in this circuit, we are asked to find the current here, I. And in order to do that, we need to actually apply Ohm's law to find the voltage across. There are multiple ways of doing this. One option is actually to use a node voltage method. You can use mesh current method if you want. You can verify this with mesh current method. So I'm going to use node voltage method. I'm going to have so this is the reference node. This one is V1, V2. So I here will be minus V2 divided by 2, or divided by 3. So I need to find V2 and then divide it by 3 and take the negative side of that, and this will give me the current I. So let's try to apply the node voltage method here. So starting with V1. So V1 minus 12 divided by 6 plus, again, I'm applying KCL here. V1 divided by 6, V1 minus V2 divided by 3 equals to 0. I can simplify it to get 2 over 3 V1 minus 1 over 3 V2 equals to 2. So this is the first equation. Again, here, since I have two unknowns, two node voltages, I have two equations with two unknowns. I don't have any dependent source, so I don't have any constraint equation. So let's apply a node voltage method to node 2. So V2 minus V1 divided by 3 plus minus V2 divided by 3 minus 8 equals to 0. And if I simplify it, I will end up with minus 1/3 V1 plus 2/3 V2 equals to 8. So I have two equations, two unknowns, so now I can solve. Two over 3. Again, you can do this with your calculator. This one should be 2 divided by 3. V1, V2 equals to 2 and 8. So I'm going to get, if I solve it by calculator, V1 will be 12 volts, V2 will be 18 volts. So remember, I here is by Ohm's law is 0 minus V2 divided by 3. So it's going to be minus 18 divided by 3, and this is going to give me 6 amperes. And that's the solution. Ahmed, a question?
الدكتور، السؤال اللي كنت بسألك إياه بداية المحاضرة
Yes.
يشبه السؤال هنا، أقدر يشبه هذه السيركت، ممكن أسأله ولا؟
Yes, go ahead, but please, شباب. Okay, go ahead.
الدكتور، لو افترضنا أن 3 أوم اللي على اليمين مو موجودة.
Yes.
التيار اللي على الستة كم يساوي؟ الستة اللي بالنص.
It depends. We need to apply KCL.
KCL ما أقدر إني أطبق current divider rule.
There is a voltage source here.
ما أقدر. طيب ما يعتبرون انبراد الستة ستة؟
No, there is a voltage source here.
وإذا كانوا in series وبينهم voltage source.
You need to give me a circuit.
Okay, شكرا.
Okay, this is the first question. So let's try to solve. It's a direct application of. Again, you are free to choose any method in this problem. I just want to point something out here. So I'm solving these problems, but it's not necessarily that this is the format of the midterm. Those are just some problems. They happen to be part of all the exams, and it's not necessarily that this is the format of the midterm. So just like giving you extra problems to solve, but if you solve all of these problems, you should be good when you do the midterm. Okay. So let's move on to this part, and let's think about what we can do with this circuit. So in this circuit, we are asked to find the voltage V, and we are given the circuit, and it's a multiple choice question. So what's the best way to approach this problem? There are multiple ways actually. You can apply node voltage method, and this is going to give you the value of V, or you can apply mesh current method. You can apply KVL and KCL and see what's going on. You can apply, well, again, superposition is not going to be applicable here, but there are multiple ways of doing this. So let's apply mesh current method. For mesh current method, we know that the mesh current here, if I call this one IA, this one IB, I know here IA equals to 2. Let me just state it here. So again, there's some, you need actually to stop and think about what's the best way to approach this problem. The reason I solved it very quickly because I prepared for this. So the stage of where I stopped and think about which method is better than the other is already been done. So I'm just like I know now for sure it's mesh current method will give me only one equation. Of course, and the constraint equation as well. So if we apply the mesh current method, we know that IA equals to 2 amperes. Then we only have one mesh that we need to solve for. Also, I know that Vx is actually 2 IB. So the unknown term, the Ch1 equation, I can directly substitute. So in this case, if I apply the mesh current method in loop B or mesh B, I will get IB minus 2, which is IA here, plus 2 plus Vx, which is 2IB, plus 2 multiplied by Vx, which is 2IB, equals to 0. So what I will get is 8IB equals to 4. In this case, IB equals to half. Okay, but again, I'm not interested in finding IB. I'm interested in finding this voltage. So this voltage is, by Ohm's law, V equals to 2 multiplied by the current. The current is going to be 2 minus 1/2. And this is going to be 2 multiplied by 3 divided by 2, which is 3 volts, which is the solution to this problem. Okay. So let's think about another problem that we need to solve. عبد الإله.
اي دكتور، لو استخدمت النود فولتج ميثود في السؤال بيصير كمان عندك 2 equations نفس الشيء ولا؟
I haven't tried it, but you can try it.
Okay.
You should end up with the same solution. You can try this one. This is the good thing about solving problems in chapter 4. So you usually have more than one way of solving this problem. So if you have one problem, you can actually create 3 different problems out of it.
Yes.
Good. طيب, so I think
excuse me, doctor.
Okay.
I solved it, but I got -3.
No, it should be 3.
The current should not be IB minus IA.
It should be IA minus IB.
Oh, positive up. Oh, sorry. Thank you.
Okay, let's try to solve another problem. Okay. So in this problem, we're asked to find the value of R such that the voltage V equals to 0. So what does it tell us here? So the statement of the problem is kind of like tricky here, but deep down, it's kind of like simple. So what we are asked to do, we are asked to find the value of the resistor here, R, such that the voltage V is 0. So what is the voltage V? So let me draw the circuit here. I don't like this type of drawing, so let me do it in what I think it's easier to visualize. So this one is 4. This one is 5. This one is 12. This one is R. So this is V. Okay. So if I call this one A, this one B, then V is simply VA minus VB. So what I need to do, can I find VB? I can easily find VB because I know the resistors and they are in parallel with the 10 volt source. So I can apply voltage divider law. So what I need to do is I need to find VB. Then I need to find R such that VA is equal to VB. So in this case, what is VB? If V equals to 0, this means VA equals to VB. So let's try to find VB first. So what is VB? VB is, by voltage divider law, 12. 4 plus 12 multiplied by 10. And this is going to give me okay, why? Okay, 12 divided by 16. Okay.
2.5.
2.5. Yes. So okay, 120 divided. Okay. No, I don't think it's 120 divided by 16. It cannot be 2.5.
No, it's 7.5.
It's what?
It's equal to 7.5.
7.5.
Yes, yeah, that makes sense. It cannot be 2.5. Okay, volts. Okay, now I found it. So what is VA? VA is simply R divided by 5 plus R multiplied by 10 equals to, that's the reason I did not calculate the final value. Because I have 10, so this will cancel. So what I will get is R plus 5 divided by 5 plus R. I'm sorry, R divided over 5 plus R equals to 12 divided by 16. So if I solve for R, I should get 15 ohm. So if R equals to 15 ohm, then VA will be equal to VB, and it's going to be equal to 7.5. Yusuf?
Doctor, how can we use the voltage divider? It's not. We must have the voltage source in series with the resistor.
Okay. In this case, what's the voltage here? Let me use the
10 like the voltage source.
Yes. Can you apply voltage divider law? Think about it. There is an imaginary source here, 10 volt, connected between this terminal and that terminal. And can you still apply KVL? Can you still apply voltage divider law? I think you can. Yeah. Right. Think about it this way. If voltage divider law is derived from KVL, right? KVL and Ohm's law. So the voltage from here to here is equal to 15, is equal to 10. So V equals to 10 equals to V of 4 ohm plus V of 12 ohm. And this one is VB.
Yes, I think I get it now. I think I have seen a question like this. Maybe the sample quiz you have posted.
Maybe. I don't know. I don't remember. Salman?
Doctor, why did you use the voltage divider for the 12 ohm, not for the 4 ohm?
Okay. Oh, you're saying like why? I want my reference point here is this one. This is the 0 volt. So
I use the upper line as a reference.
You can use it. So, but here you need also like to use the upper line as well to find VA. So you have to be consistent. Okay, good. This is a question that I do like, but let's solve it. So we're given the following circuit. I don't like it because it doesn't test it doesn't test your understanding. It tests your ability to visualize things. Anyhow, okay, so this is the circuit we have, and we are asked to find the equivalent resistance between A and B. So the first thing I usually do is realize that, well, these are connected. It's exactly one node. And also, like, I need to draw it in a much better way and a much easier for my eyes to recognize things. So I combine the 2 kilo with 2 kilo. This is going to give me 4 kilo ohm. I notice here that this node is connected to the ground, or connected to this big node. And actually, it's in parallel with 2 kilo ohm. Similarly, this one is connected to that node, and it's actually in parallel with 2 kilo ohm. Now, this circuit is much easier to visualize. Now, if I ask you to find the equivalent resistance between A and B, what you would say, you would start with this combination and this combination. So you have 2 kilo ohm in parallel with the short circuit, so the equivalent resistance is 0. Another one, 2 kilo ohm in parallel with short circuit, the equivalent resistance is 0. So if you simplify it, you will end up with something like this. This is A, this is B. Now, in this case, you have 4 kilo ohm in parallel with a short circuit, so the equivalent resistance is 0. So the trick here is actually the way the question or the circuit was drawn. Okay. Hassan?
Doctor, the resistance parallel with short circuit.
Yes.
Equivalent is 0.
Yes.
And
So
if it is parallel with the open circuit.
It's the resistance itself.
Yes.
It's the resistance itself. So the current resistance is the resistance. So what's the resistance of an open circuit? It's infinity. What's the resistance of a short circuit? Is actually 0. So apply the equivalent or the equivalent resistance. You will see you will find the values here. Good. Okay. So let's see what we have. We have in this circuit, it says that the current through 2 kilo ohm resistor is given by this formula. And we are asked to find the total energy absorbed by the resistor up until t equals to 6 seconds. Okay. So remember, the energy is what? The integration of the power. And here we are asked to integrate from 0 to 6 the power integrated with respect to time. So what's the power here? We are given the current. We are given the reason we set 0 because there is no current for t less than 0. We are given the current. We are given the resistance. So power is I squared multiplied by R. So I is for t milli multiplied by 2k, and this can give me 32 milli t squared watts. So this is the power. So all what I need to do is integrate it from 0 to 6, 32 milli t square dt. And if I do the integration here, I will end up with 2.3042. Okay. Very good. So let's solve another problem here. Oops. Okay, so let's see what we have in here. So we're asked to find Ix, this current, in the following circuit. So you may ask yourself, what is Ix here? Well, what's the best way to approach this problem? So this circuit is not that complicated. The only complication here is you have more branches. You have, you have 1, 2, 3, and 1, 2, 3, and 4 branches. That's going to somehow complicate the analysis. But if you think about a way to simplify them, things will be easier. So let me, instead of finding Ix, let me find I here. Let me call it I1 here. So what's the relation between I1 and Ix? So I1 is, or let me write it this way. Ix is 2 divided by 3 multiplied by I1. So I'm using the current divider law. So Ix is going to be I1 multiplied by 2/3. The resistor that I'm not interested in, divided by the summation. Okay. Now if I know this, once I find I1, I can easily find Ix. So let's now change the problem to finding actually I1. So if I need I1, I need actually to simplify the circuit. I have 10 amperes here. The parallel combination of 1 and 2 is 2/3. I have 1. I have 3. So now this is I1. Now if I ask you to find I1, I assume you can easily do this using current divider law. So I1 will be 3 divided by 3 plus 1 plus 2/3 multiplied by 10. And if you solve for it, you will get 45 divided by 7 amperes. Okay, now I found I1. So I will go back to this equation and find Ix. So Ix is 2/3 of this one. So I should get 30 divided by 7. And this is exactly what I have. Ahmed?
Doctor, what about if I combine firstly the two resistors in parallel?
Mm-hmm.
Those two resistors. Then I do divider rule,
Mm-hmm.
current divider rule. Then I do the current divider rule between those two.
You can, yeah. I mean, you should get exactly the same answer.
Oh, okay, thanks.
Okay, So let's try to, this is 2, this is 4. Okay, let's try to solve the following problem as well. Okay. We're asked to find the power delivered by the voltage source. So let me ask you this question. If I tell you find the power delivered by the voltage source, so what do you think the what do you think the heading assumption here? Mohammed?
It will be negative.
Yes, it will be. I mean, the power that I need to find, it should be negative. So I'm assuming the source is generating power. So if I end up getting positive, what should I write? Should I choose the positive here or the negative? Ahmed?
Generate.
No, I mean, if I end up getting positive, what should I use? Should I use the positive or the negative? Okay, here I'm assuming that the power delivered, let's say like I did my calculation here, or okay, let's try to solve it and see what's going on. This might explain. Okay. So if you want to find the power generated by the voltage source, I need to find the current of that source. So the current of that source is actually 2V. So P will be, and this current is flowing from the positive to the negative. So it should be, according to the passive sign convention, 2V multiplied by negative 3 volts. Okay, so what is V here? V is actually the voltage across the voltage source, which is negative 3 volts. So if I do my calculation here, I will end up with 2 multiplied by V, which is negative 3, multiplied by negative 3, and this is going to give me 18 plus 18 watts. Okay, so the correct solution is actually negative 18. Why? So what does this one tell me? What does it tell me? The Kareem?
My current place is opposite. It's wrong. It's going from the minus.
No, we're talking about the power here.
He said in the question that's delivered.
Okay, that's the assumption that I make. Now I did my calculation. I found it to be positive. Abdullah?
Dissipates power.
Yes, the source is actually dissipating energy. So my assumption here, if I tell you what's the power delivered by that source, what can you say? You will say that, Muhammad.
Since we assume that it's delivering and we got a positive, so our assumption is correct. So it will be minus 18. Is that correct?
Our assumption is incorrect. Here, when we did the calculation, we did not assume anything. صح? We treated it as if it's a source. If it's something that, if it's an element that we are trying to find the energy or the power associated with it. Okay, so we're treating it like an element. We're trying to find the power associated with that specific element. Now, since we did the calculation, we found that this element is actually absorbing energy. So the solution to this problem, if I give you this problem, if I said like instead of delivered, I would say find the power associated with the voltage source. then in this case you should choose the positive one, because this source is generating power. Now, since this source is actually the power is I'm saying like how much power this source is delivering. And you did your calculation, you notice that this source is not delivering, it's actually absorbing. So the negative sign here indicates that it's my assumption, it's against my assumption. So it's not what I assumed. It's clear, Shabab? Because here there are 3 ways of asking such a question about power. The first one is find the power associated with elements. So in this case, it's an open-ended question. If it's positive, you say like this element is dissipating. If it's negative, you say that this element is delivering. The second question is find the power delivered by. So you're saying like, I'm saying that this element is delivering power. And you did your calculation, you notice that this element is not delivering power. This element is actually absorbing power. So you need to tell me 2 things. You need to give me the value and you tell me my assumption is incorrect. So the value is embedded, is clear here. The value is 18, for example. Telling me my assumption is incorrect is within this negative sign. The last way is find the power absorbed by. So I did my calculation. I found that the power is negative, which means that the source or that element is actually generating power. So in this case, I would give you the value and I will give you a negative sign. So the negative sign is telling you that your assumption is incorrect. واضح يا شباب؟ عبدالله؟
طيب يا دكتور لو جاني ذا السؤال بس بدال delivered by جاني absorbed by أصير أختار negative 18.
No. If this question is asking you find the power absorbed by, then you should choose positive 18.
لأن our assumption was correct.
Yes.
Okay. See.
I believe there is another question in this. Hassan?
دكتور لو قال لنا طيب absorbed وطلع الناتج minus 18.
Okay. In this case, I tell you it's absorbed, and the solution was minus 18. So in this case, you're saying like this element from the calculation, you notice that this element is actually generating, not absorbing. صح?
Yeah.
So you're giving me the value and you give me the negative sign indicating that my assumption is incorrect. So it's going to be negative 80. I believe there is another question. Okay. Yeah, there are few questions. We'll come to them, inshallah. But this is the logic behind it. Ahmed, I need to move. Your question is very quick. Please ask.
الدكتور معناته بما انه طلع لي موجب معناته ان الفولتج سورس معكوس صح؟ فمجرد ما اني اعكسه راح تطلع النتيجه صح.
No, we already take care of that when you did the calculation.
Okay. Because you bought minus.
Yes. Let's try to solve this problem. And we are asked to find which one of this equation is a valid supernode equation. Again, where is the supernode here? This is the supernode. So which one is actually a valid supernode equation? So let's find the supernode equation and see which one of them is actually the supernode equation. So the supernode equation is going to be V3 minus V1 divided by 4 plus V3 divided by 8 plus V2 divided by 4 plus V2 minus V1 divided by 2 equals to 0. So if I simplify it, I will end up with, well, clearly here there's no fraction. Nothing is divided by 8, so I might as well, I might multiply each term by 8. If you multiply the right and left hand side by 8, you shouldn't, the value should not change, or the result should not change. So if I multiply them, I will get 2v3 minus 2v1 plus v3 plus 2v2 plus 4v2 minus 4v1 equals to 0. So if I group terms, I will end up with 6v1, negative 6v1, plus 6v2 plus 3v3 equals to 0. So this is the supernode equation. I don't see anything like this. This one cannot be this equation. This one cannot be this equation. This one is missing clearly. This one, well, to eliminate this equation, it's clearly that the first term here, the term associated with V1, is equal to the term associated with V2. So this eliminates this equation, the value. Here, this one could be a good candidate, the second one, but remember, we can see here that the term associated with V2 is actually twice the term associated with V3, which is not valid. This one does not have V1 in it, so this is not valid. Clearly, this one is actually not a valid one because I have 3 here, and if is not an option, or if it's one of the options. So now if I divide both sides by negative 3, I will end up with minus 2v1 plus, or I divide every term by negative 2. So I'll get 2 minus 2v2 minus v1 minus v3 equals to 0. So divide
-3, not -2.
Negative 2. Yes. Negative 3, yes. Okay, good. So let's move on to so this exercise is asking us to, or this question, it's the same circuit, but it asks us to find V1. So this is 4, this is 5. So what is V1 here? From the previous analysis, we found we need to apply, again here, it's a not voltage, so we need to apply, clearly we need to apply the not voltage method. So V1, first of all, we can, it's the same circuit, so we can carry the same analysis from the previous case. So we have one equation here, which is 2v1 minus negative 2 minus 2v2 minus v3. So this is going to be our first equation. Now we need to have two more equations. So the first one is applying the node voltage here. So it's going to be V1 divided by 2 plus V1 minus V2 divided by 2 plus V1 minus V3 divided by 4 equals to 0. So if I simplify it, I will get 5 over 4 V1 minus 1/2 V2 minus 1 over 4 V3 equals to 0. If I do the same approach like I did last time, multiply everything by 4, I'll get 5V1, 2V2 minus V3 equals to 0. So now I have two equations. I still need one more equation, so I can apply KVL here. So this one is V2 by KVL. It's going to be V2 equals to 5, or let me write it this way, minus V2 plus 5 plus V3 equals to 0, or V3 minus V2 equals to, V2 minus V3 equals to 5. So now I have three equations, three unknowns. I can easily solve for it. Actually, this is one of the, if you go back here, this is one of the equations. And this one is actually, and this one is actually the other equation. Okay, so V1 equals to 0, V2 equals to 1.67 volts, V3 equals to negative 3.3 volts. So V1 again here is 0. So nothing is complicated here. We need to apply voltage. We need to apply the node voltage method, but with the solver node. Okay, let's see what else we have. Okay, this is again the same circuit, but in this portion we're asked to find the power delivered by the voltage source. So in order to find the power delivered by the voltage source, we need to find the current supplied by that source. So nothing fancy here, simply standard relation. So find the current, and from this current you can actually determine the power. So let me do the following. So let me take this portion of the circuit, cut it, and draw it here. Okay, I did not do anything here. I just simply took that portion and kind of like magnify it, give myself enough space to work the problem. So now, in order to find the current, I need to apply KCL here. So if I call this one I1, I2, and let me call this one IS. So just by KCL, IS equals to I1 minus hold on a second.
minus I2.
This is yeah. Just want to make sure that I don't do any issues here. So I1 minus I2. Okay. Okay. So what is I1? I1 is actually V1 minus V2 divided by 2. So V1 is 0. V2 from the previous analysis was 1.67. So it's going to be, okay, minus 1.67 divided by 2 amperes. I2 is going to be V2 divided by divided by 4. So V2 divided by 4, and in this case V2 is 1.67, so it's going to be 1.67 divided by 4. So IS will be 1 minus 1.67 divided by 2 minus 1.67 divided by 4, and this is going to give me 1.25 amperes, negative 1.25 amperes. So now I need to apply in order to find the power, this one is 5 volts. So P equals to I multiplied by V according to the passive sign convention. So it's going to give me minus 5 multiplied by, minus 1.25 multiplied by 5, which is minus 6.25 watts. So this is the bar, and it's minus 6.25. Again, here, I'm assuming that the bar is delivered. So I'm getting a negative side. So it means that my assumption is correct, and the value of the bar is 6.25 watts. Okay, is it clear, Shabab? Ali?
Doctor, so on the exam, should I write it in positive? If it was a negative, or it's okay if I write it negative. I keep it like what I calculate.
No, here's can you explain the question to me? This question statement, Ali.
They need the power delivered by the voltage source.
Yes.
Yes. So it should be negative, the power that I will calculate.
Yes. So if you tell me that, if I ask you this question, Ali, what's the power delivered by the voltage source? What should you tell me now?
It is 6.25.
Why didn't you tell me negative 6.25?
Because you need the magnitude, I think.
Is that what I need?
Okay.
No, is
Yes.
that what I need? No, this is a question. Is that what I need, Ali?
You need the assumption is negative, I think. So.
No, it's very important. I'm not pinpointing you, so it's very important that we clarify this issue before we move forward, because there's a philosophical point associated with this type of questions, and I really don't like. But this is an exam that I don't have any control over. This was actually 182. I wasn't even here at KFUPM. So what's the conclusion here? What's the conclusion? I mean, if this question is telling you that the power is actually delivered, I'm telling you the power is delivered. So what's the power delivered by default?
So it doesn't matter what's the sign. If it was wrote.
No,
like
it really matters. It really matters. Here I'm assuming that the power is delivered. So this is the underlying assumption. Then you solve the problem and you found that the power is actually negative, which means that my assumption is correct. صح?
Yes.
So you tell me that your assumption is correct by saying that it's positive, and you're giving me the value.
Okay. Because sometimes in the book they wrote negative, sometimes no, not.
It's exactly the same thing. That's exactly the same thing. So in order to do that, you need to go back to the question statement. If it tells you, find the power delivered by that source, it means that the assumption, or you should get a negative one, negative value of the power. You ended up getting positive. It means that the power is actually absorbed. So you need to tell me two things here. You need to give me the value and tell me that my assumption is incorrect.
So in the exam, I should write.
In the exam, Ali, we cannot work like this. We cannot work in the exam. Do A, B, and C. I'm not here to teach you.
I understand what you mean now, Doctor, but I mean to not lose some points.
No, I mean you need to understand. If you understand it, then it will not be a point that confuses you anymore.
Okay.
Abdullah.
So, Doctor, whenever my assumption is correct, we put a positive answer. We have a different assumption. We will put a negative sign, basically.
Yes.
Okay, thank you.
Yes, you explain it in a better way. Thank you. Okay, let's see. This circuit, in the circuit shown below, find the power in watts delivered by the 1 ampere current source on the left. Ali? Ali?
Yes, Doctor.
Ali, what's the assumption here?
We will use mesh analysis or mesh method.
No, not the technique. What's the assumption when we do the power calculation?
The power delivered.
Okay. So if we get positive, what does it mean?
It means that my assumption is incorrect.
So you're going to give me the value and you give me the message that my assumption is correct. I can understand it from the negative side, right?
Yes.
Exactly. And actually, if you do the calculation, you will get negative. Okay. Let's. Okay. Delete it. Maybe use another page. طيب شباب okay Ali, okay, you're saying that we need to use the mesh analysis. Okay, maybe this is a good point to clarify some of these assumptions. I'm about to lose my voice, so I'm trying to optimize the problems that I'm going to solve. Okay. Okay, let's try to solve it. Ali, you said we need to use mesh analysis, which is correct way to correct approach, because mesh analysis is, in this case we have this one is known, this one is known, and this one is unknown. So we have two, basically we have one unknown equation. Okay, let's see what we have. Okay, so we need to apply mesh analysis here. So if we apply mesh analysis here, you'll have 5 IC minus 1 plus 10 IC minus 2 plus 10 equals to 0. So IC in this case will be 15 divided by 15 or 1 ampere. Okay. So now, in order to find the bar associated with, or the bar delivered by the 1 ohm current source, I need to find the voltage. So in order to find the voltage, I need to apply. I say this is the voltage. This is the voltage. Let me call it V2. This is V1. And oh, I'm sorry, this is, let me call it Vs. This is V2, this is V1. So Vs is going to be V2 plus V1. So what is V2 here? So V2 is the voltage across the 10 ohm resistor. So the 10 ohm resistor is going to be, by Ohm's law, 10, 1 minus 2, and this is going to give me minus 10 volts. V1 is the voltage across the 5 ohm resistor. So it's going to be 5 multiplied by 1 minus 1, which is 0 volts. So Vs is minus 10 volts. Okay. So now let's find the power. So the power, remember here the polarity, this is Vs. So according to the passive sign convention, I should get negative 1 ampere multiplied by Vs, which is negative 10. And in this case, I'm getting 10 watts. So what does it tell me here? It's actually absorbing power. So my assumption is incorrect. It's going to be negative 10. So for the same circuit, let's see what happens when we have a current, when we try to measure the power delivered by the 10 volt source. So this is the 10 volt source. So I need to find the current. The current in this case is IC. So the power will be, oh, I'm sorry, the current passing through the source will be IC minus 2 ampere. I call this one IX. IX multiplied by V. So IX is 1 minus 2 multiplied by V, which is 10. So it's going to give me minus 10 watts. So yes, this source is actually delivering power. So my assumption is correct. So I'm getting positive here. Is it clear, شباب?
Yes, clear.
Okay, very good. طيب, I think I need to stop here. I really cannot. Don't. Yeah, the remaining problems are not that complicated in this exam. Let me see another exam. Yeah, the remaining problems are not that complicated. Any questions, شباب؟ تفضل أحمد.
دام فضلك الدكتور ممكن ترسل المذكرة مع الأجوبة؟
Yes, I can send this one.
With the solutions?
Yes, with the solutions.
Thanks.
But not the one I solved and did not solve here.
Again?
Not the ones I solved and did not solve here, because I will spend so much time explaining what I did, because it's really hard to.
The steps. The solution was the steps.
Yeah, this one.
Yes.
Okay, yes.
Thanks.
عبد الله الإله.
يا دكتور ممكن تطلع سؤال 11 الحين في المش اللي تحت على اليسار شلون حددت التيرمينالز يعني تحت النيجاتيف وفوق البوزيتيف ولا هذه
assumed
وعادي لو كان الاسيوم غلط ما يفرق الاسامبشن
You want to try it? Let's see. تبغى هذا بوزيتيف؟
ايه بس كذا
VS plus V2 plus V1 equals to 0, so you'll get negative VS, or in this case me, because eventually I need VS, so let me make it positive, minus V1 minus V2. طيب. So V1 and V2 are given, so VS here is going to be 10 volts. Okay. And واضحة VS is 10 volts. So if I do the power calculation, according to the passive sign convention, I should get positive. 10 multiplied by 1. This is going to give me 10 watts, which is exactly the same. So I need to delete it not to confuse. But yeah, you can assume any direction. Okay, any other question, شباب؟ طيب الله يعطيكم العافية وبالتوفيق.
الله يعافيك.